Hey there, Seahawks, it's Miss Adams, and in this video we're going to talk about linear regression and residuals. Alright, so linear regression describes how a response variable, y, changes as an explanatory variable, x, changes. Alright, we use this to predict the value of y for a given value of x. The most accurate regression line is the least squares regression line, or the LSRL. All right, this helps to minimize the errors squared of the y. It always passes through x bar, y bar, the ordered pair x bar, y bar, where x bar is the mean of your x values and y bar is the mean of your y values. It is not resistant to outliers, so outliers do affect the line a lot. To get this on your calculator, you would go to Stat, Calc, Option 8, Linear Regression A plus BX on the 84. And then we'll replace x and y with their unit names when we're writing the equation. All right, so this is so that we have it in context. All right, here's our equation. So y hat, it has a little like top piece of a triangle on top of it. That tells me that I'm working with predicted y values. A represents the y-intercept. B represents the slope. And then there also is a formula. These formulas are all on your reference sheet. There's a formula for slope, which is the correlation times the standard deviation of y divided by the standard deviation of x. And another formula you could use to find the y-intercept if you know the slope, or if you need to find the y-intercept given the slope, if you know the mean of x and the mean of y. So the mean of y is equal to a, the y-intercept, plus b, the slope, times the mean of x. All right, residuals and errors. So let's say that I have my scatter plot here. I can have my line of best fit going through those points. My residual is this distance from the actual point to the line of best fit. So it's the amount of error in my line of best fit. All right, it's calculated by the actual y minus the predicted y. That's how I would calculate the residual for that specific point. All right. Same thing below the line. All right, I can have positive residuals and I can have negative residuals. Okay, actual y minus predicted y. Sum of the positive errors is equal to the sum of the negative errors. The sum of the residuals should be equal to 0. And the mean of the residuals should be equal to 0. All right, so these are some things that maybe might come up as a multiple choice type question. Extrapolation, using an x value far outside the range of data given to predict a y value. All right, extrapolation is not trustworthy. It might not continue to follow the same type of linear relationship. All right, so if I have data from 2000 to 2015, I wouldn't want to make a prediction about 2025 because that's far outside of the data that I have available to me. And so there may be some things that come along in life that change that pattern that we've seen going on from 2000 to 2015. It might not continue with that same pattern. All right, coefficient of determination. The symbol for that is r squared. All right, and then we have like a stock sentence for interpreting this. So your r squared value as a percentage of the variation in your y variable can be accounted for by the least squares regression line using x equals whatever your x variable is. Okay. Interpreting slope. Again, the symbol for slope is b. Our sentence interpretation will be for each additional x variable in units, the predicted y variable either increases or decreases depending on if the slope is positive or negative by whatever your slope units are. Like so the number and the units for the slope on average. Okay, on average is important. Okay, remember that slope is an average rate of change. All right, residual plots are a scatter plot of the x variable versus the residual. All right, it helps us assess the fit of the least squares regression line. You must run a linear regression on your calculator first in order to for your calculator to make a list of the residuals. It will do it automatically as soon as you run a linear regression. No pattern or scattered, that means our line is a good model for the data. So we want to see the residuals scattered with no obvious curve or pattern. If it has a pattern or a curve, another model or equation, maybe quadratic, exponential, something like that, would be a better fit for our data. All right, so again, if our residual plot is scattered, this is good. This is what we want to see. All right, some bad residual plots would have a curve or a pattern. All right, this one here in the middle, we call that a fan or a horn pattern. All right, putting it all together. So we have different airfare, so how much it costs to go to these different locations, and the distance it would be traveling. So from whatever the home base is to Atlanta was 576 miles, and it cost $178. All right, so we have this data here. We're going to put this into our calculator. So put data in our calculator, we would go to Stat, Edit, and then List 1 and List 2. I would put in distance in List 1, airfare in List 2, and then I can use that to get a least squares regression line equation. I can get R and R squared, and then I could also have the calculator make the scatter plot, or I can just make the scatter plot. All right, so I kind of did a sketch here of the scatter plot. You can use the calculator. It's second y equals is your stat plots option. Once you have the data in, you can pick the option that looks like a scatter plot. Make sure that you have labels and some tick marks. So I went ahead and had at least 2 tick marks on the x-axis, at least 2 tick marks on the y-axis. And I labeled my x and y-axis. All right, so to get my equation, I'm going to go to Stat Calc option 8, which is ln reg a plus bx. All right, and I get y equals 83.27 plus 0.17x. For y and x, I'm going to plug in my variables. So my y variable was airfare, so it's predicted airfare. Okay, I'm making a linear regression equation for the predicted y values. So airfare needs to have that hat on top of it. And then my x variable was distance in miles, so I put that inside of my parentheses. Okay, you want to plug the context in there. All right, R was my correlation coefficient, which was 0.795, and R squared was my coefficient of determination, which was 0.632 in the calculator. So we would go to Stat, Edit. Again, we put our data in here. So we're going to go to Stat, go over to Calc, option 8, linear regression. My X list is going to be list 1. My Y list is going to be list 2. I'm going to go down to calculate. It's going to give me A, B, R squared, and R. So I plugged all of those into my equation. So remember, it's y hat equals A plus BX, and it gives it to you right here. So I'm just plugging it in. And then for y and x, I'm also plugging in the context. Do not forget the hat. Okay, it's very important that you have that hat over your y variable. It does not tell you that there in this little piece on the calculator. If you wanted to make the scatter plot, you can go to second y equals. You're going to make sure only one of your stat plots is on. I'm going to choose the type that is a scatter plot. My X list is going to be list 1. This is probably how it's set up in yours already. And my Y list is going to be list 2. Once I'm ready to make the graph appear, I'm going to hit zoom and then option 9, which is zoom stat. All right, and you can get the trace. You can hit trace. And this is kind of what I did to get my scale. All right, now we can also make our residual plot. So we can calculate all of the residuals. Our calculator actually did that for us. All right, so we go to second y equals, which is stat plots, and I'm going to change my y variable to the list called resid, and then zoom 9, and you'll get your graph. It looks like this, and our interpretation sentences. So for R squared was 0.632, so 63.2% of the variation in airfare in dollars can be accounted for by the least squares regression line using x equals distance flown in miles. And then for the slope, my slope was 0.12. So for every additional mile flown, the predicted airfare increases by 12 cents on average. All right, again, let me show you how we did this residual plot. Okay, so for the residual plot, we're going to go to second y equals. That's our stat plots. We're going to go on. We're going to change our y list to the residual list. So if I go to second stat, that gives me the list options. Because I did stat calc 8, every time you do stat calc 8, it repopulates a new residual list. All right, so you're going to always have like a residual list once you've done it one time. You want to make sure you ran the residual, like you ran the linear regression to get that new residual list. All right, so we do resid and then zoom 9, and then you can see our residual plot here. Again, you can press trace and go to different points to kind of help you get a scale on your X and Y axis. Go Seahawks!